and welcome to our second of the 6 sessions we have today in the AECB online conference. I'm Duncan Smith, the Chief Operating Officer at the AECB, and joining me as host, or co-host, is Andy Simmons, as well as Jeff Coley. Andy is our Chief Exec, and Jeff is the editor at Passive House Plus. Sue and Sam are pulling all the levers that work in the background to make this go smoothly. The aim of the conference is to engage with our AECB membership, which has grown significantly over the last year or so by 20%. And we want to try and showcase some of the great work that is going on out there in the community, the AECB community, and wider. But we also want to reach out to non-members as well and highlight the benefits of becoming an AECB member, and whether you're an individual or a company, we'd love to get you on board or hear from you. Before I introduce you to our two speakers, Tim and Jurgen, I just want to tell you the format of the session today. So we're on just now from 10:30 to 12 o'clock. And we've got 2 presentations, followed by a Q&A at the end of each presentation, like I say, with a wrap-up of about 12:30. Now, if I could ask you to keep the questions in the Q&A, it would be great. The chat is fine, but we sometimes kind of lose the thread of who's asking what. So if I can keep the questions to the Q&A, we'll aim to answer the presentation that Tim gives, and then we'll move on to Jurgen's presentation. So that would be great. We'll be recording these sessions and putting them onto our AECB YouTube channel, and we'll be using live subtitles at the session today. So for anyone who's hard of hearing, if you click on the CC caption at the bottom of Zoom, and you can display subtitles through there. So details, we've got Tim talking about the AECB's PHribbon software, which we just launched in the online shop last week. And we'll, in a minute, be asking him to take that away. And then at 11:30, we've got an introduction to PHPP10, which will be given by Jurgen Schneiders of the Passive House Institute in Germany. So you probably know, many of you probably know who Tim is. He's an AECB software and research and development lead. And Jurgen is the Managing Director of Passive House Institute in Germany. So without any further ado, Tim, can I ask you to share your screen and take it away?
Hello, thank you very much. So what I'm going to do is give you a little run through of what PHribbon is doing these days, and with very specific mention about what's changed for version 10, because it's now version 10 compatible, and a few things had to change in that process. What I'm going to do is just run through things pretty briefly, like as an overview, just so you can get a flavor of what it does. PHribbon, we're in PHPP here. You might notice it's version 10. PHribbon is a toolbar which is installed in Excel, just like any other of the standard toolbars. And I think it might be simplest just to go through a few things in sequence. So climate, for example, allows you to select a climate region by seeing the actual counties, the actual county boundaries. That's quite useful. And you can pick them, and it'll put all the things, all these entries in one go. It'll even save the map position for you as well. The U-values, well, the U-value format, we're on the U-value tab here, and the format of that has changed in version 10. And what this can do for you is it can help you transfer information from your version 9 data to your version 10 PHPP. So if you have a lot of entries that you've already built up over the years in version 9, you can transfer them by copying them into the library. And this library has been extended to 150 entries. So that should allow plenty of room for you to put all your entries in. There's some standard ones in there too. And the layout of this, for those who remember the last one, or aware of the previous one, the layout has been a bit simplified, because all we're doing essentially, conceptually, what we're doing is just copying and pasting. It doesn't actually copy and paste, because we have to be careful about doing that in PHPP. So it's just a matter of picking an entry using the up and down arrow, picking a a library entry, and then we could paste that new entry in there, and it will replace all that with that one. And copying information from the old ones is just really straightforward. You just do this process in the old one. You build up a library, it will add to these entries here, and then you open your new one and you paste them in there. And you can also clear the entries and clear the library entries too. Orientation is a little bit different, because people do from time to time rotate their buildings, and they want to see how it looks, how it performs when it's rotated. And to do that, you have to have a master cell somewhere. You have to have a master cell which allows you to rotate all the elements from one individual cell. So that master cell we've chosen as a north, and if I go to this one, it will actually color it. But if I said that master cell was a bearing of 5 degrees, I've done it before, that's why it's already colored, but it will color it if it's not colored, color it a deeper yellow, in other words. Then when you go to, so you can see that's north. I hope you can read that. If you can't read that, then just have to rely on my explanation. There's a north row there, and then this entry here is a south row. So if we went up to that one, we could then allocate that to a south there, and we could do the next one, which is a west, allocate that to a west. And then that means that if we finish that, I've only changed these few, but if we change that figure to say 15 degrees from north, then it would change these, and it would also correct so that they're always between 0 and 360 degrees. And you can do that with the others. I've only done it with a few. Absorptivity, this is a thing that we had in the previous version, just writes the absorptivity in these 3 cells here, the reduction factor for shading, the absorptivity and the emissivity, and the list. If you actually look for emissivity of materials, what you often get is a list from Engineering Toolbox, which doesn't agree with the Passive Institute's. I think it's a mistake. It doesn't agree with those values at all. So I've chosen a source which does agree with those, the absorptivity and the emissivity, and you've got a list there to choose from, and it will write those for you. Now we come on to something a bit more interesting, windows. So windows have changed in the current version of PHP version 10 because the frame information is different. Whereas in version 9, the each entry, let's go to the window tab. Whereas in version 9, each row was a pane of glass in a window. In version 10, each row is an entire window. And so this is an example. This is version 10, as I was saying. So each one of these is an entire window. And I did think, well, actually, that means probably you don't need a window tool, probably don't need a dereveal tool either. But then when I looked into it a bit more, I thought, well, maybe it can still help, actually, because what we've got now is we've got these extra cells here that have to be entered, fixed glazing there, and if I've just scrolled over a bit, mullion length and transom length, maybe there is some help it can give on those. So what we've got now is a new version which, when you press the window tool there, it gives you similar appearance to the way it did before, but now when you select a window, it's going to write these cells. And there are a few more entries than we had before. Some of them have got different options with them. So if we pick this one, for example, we're in this row here. We can pick a width, let's say 1400 millimeters, and then the height 900 millimeters. And we have these options because it matters quite a lot which way the window is opening. The things that these cells here are written on the basis of which ones of these are opening and which ones are not. So you have all these different options for pane 1 opening as drawn, or pane 2 opening. And the situation here is very simple. There's only really 1 mullion to be worked out. But when you get to a more complicated situation, that could be a bit more time consuming. So what it does here, for example, is it works out the length of mullion, which is between, now I should say this, for those people who aren't familiar, this means this is an opening window, this little triangle here. And these two are therefore fixed. So this mullion here, this part of it is fixed. This mullion here will be defined as a different width because it goes between an opening window and a fixed window. And this one here also, this transom here, goes between an opening window and a fixed window. So this is one type of transom. There are other type of transoms. There's, on this one, you have this type of transom goes between a fixed window and another fixed window. So it works out which one is appropriate and puts it in the relevant cell. Let's go back to the one we were before. C600 and then D350. And if we put in a name, say W1, and write that, it will write the various cells. And quite a lot of these, most of them are fixed in this case. So that gets written there. So I did think that the D reveal might not be needed, but actually there are some situations where it could be useful. So the D reveal, calculator, there's an error there because I deleted a cell earlier on, or I must have put in a D reveal and deleted it. If we go up and calculate that, we can calculate this where it has a cover. Sometimes with a D reveal, you'll be designing your building so that the D reveal is fixed. So you could design your windows so that the frame is entirely hidden within the wall and all you see is the glazing edge, in which case you already know that the cover here is 0. But it will deal with situations where there is some shedding edge and a cover, and it will just work that out for you. So if I broke that one, then it would. Have we not got a window in there? Well, anyway, it'll write that for you. The next one, components. We have a lot of brilliant entries in the component database of Passive House Institute, and so all certified windows will be in there. However, we also have a lot of other windows which are not certified, which we still might want to use. So, for example, Green Building Store has about 15 or so different non-certified windows, whereas they have only one certified window, and therefore the information they've already been providing on all those windows, which works for version 9, it could be useful to have all those windows in version 10 as well. And so what this does is it converts version 9 data frames to version 10 data frames, though you do have to also add some extra information. You can just pick from a manufacturer here and it'll write the glazing type. It'll also write the frame. We could just pick a frame, and it would put it in the components tab. Once we wrote the glazing there, it's if we scrolled over to where it was, then it would show that. And again, here we can write the frame of that. It will write that as well. The actual conversion process is in the PHribbon spreadsheet. There is a check PHPP, which first of all goes to the Passive House Institute's check and their plausibility check and asks you about that. But it also goes through and allows you to check a list of common mistakes just by going through them. And you'll probably notice if you've made a mistake just by going through them. If you say number of dwelling units entered correctly, yes. Specific heat capacity entered, yes. It's a bit of more of a reminder to you. You'll probably know just by looking at it whether you actually entered that right or whether you forgot. And you can cancel and edit it if you want to correct it there and then. And when you press the button again, it will resume. I want to move on to embodied CO2 because that's a really important one. Let's see. The embodied CO2, I should just change this. This is a feature of doing this live. I've just changed the U value tab. This is very interesting cross-check that PHribbon has just done here. In the U value tab, I've just changed this entry here from a roof to a party wall. And it's now said in the areas tab that the entry that I've got here is no longer valid. So I'll just change that for the sake of argument to a party wall, even though it's not a party wall. It should match one of the entries on the U value tab. So if I start that again, it's done that check. The reason that, by the way, it does that is because in order for the quantities that PHribbon puts in for you, in order for the quantities to be accurate, these entries here have to accurately, the name has to be exactly match those given on the U value tab. Anyway, that aside, we can add start a new calculation, and this is all updated for version 10, as everything is. And it's added this new sheet, and then we can just start adding materials. Interior plaster, for example. Let's choose a more common plaster. There we are. You can write that, and then we can add a type of block. Let's choose British Precast Association block. This is really the main part of PHribbon, the most important part of it. And the embodied CO2 calculations are taking up the majority of my time because it's quite a complex thing. But from the user's point of view, it's really simple. Really, all we're doing is we're going through and picking materials and matching them up there. And on the main menu, when we want to add windows, it'll give us a list of windows. It will even allow us to compare how much CO2 is in each one. Just, that's not a complete calculation because that would be hard to do, but it gives us the manufacturing, a comparison to the manufacturing CO2. So we could add a type of window there and write that. There are things in PHPP. In fact, PHPP is all thermal units only, thermal materials. It's the thermal envelope that it's talking about. There are other materials such as finishes or internal walls or intermediate floors, which are not part of the thermal envelope, so don't have to be in PHPP. but we want to add those materials as well. And that's what this third button is for. And when you select on one of these different categories, it'll give you a special menu, which is for materials which are commonly in that location, and you can choose from those and add those. And just as we did before, write the selection. And then for services are on this other button 4, and we've just added quite a lot of Mitsubishi heat pumps, which are TM65 calculations, which are the best thing we have compared to a EPD. One step down from an EPD, but environmental product declaration, but one step from that. And it also allows us to put in the refrigerant there. And once we've done that, the results are now on the single tab, embod R tab. So some people will be very pleased to hear that they're actually a lot easier to get hold of now. You can flip between the embod tab and the embod R tab now, just to flip between the two, and all the results are lined up there, and it has all these other things. The pages which were previously defined on the other tab are now defined here. I'll mention a little bit about costs. There is say the same costing procedure is available as before, and what this does is it allows you to pick a external. This is an assembly, and it allows you to say what you do to it to make it a retrofitted component. So in this case, we would add external wall insulation. In fact, it should show that already, but you have to, it should show that it's got EWI on it, but we have to say, we have to explain to it, because it doesn't necessarily know, that this would be an external wall insulation case, and then we would select the materials that we want to account for, and it has some cost for those. You can adjust them, and when it's gone through all that, it produces a spreadsheet, an extra sheet in the PHPP, which evaluates that in terms of net present value. Running out of time, but there is a similar process for the variance and the step-by-step, which this time works with the variance tab of PHPP, and it's been adapted for version 10 as well. The last thing I'll mention is the improvement option evaluation. This is part of the costs tool, and for those who are aware of PAS 2035, you might be a little bit worried about the process of having to put in measures individually before you've even worked out your retrofitted building. You have to start with the existing building and put every measure in individually, and then take it out again, and then put it in as a package. Well, that could almost take all day, but with this tool, it could be a lot quicker. And this is a feature that's been in the previous version, but it's been improved to make it a bit more straightforward to understand. So the improvement option evaluation, if we click on the button there, it asks us if we want to start a new calc or continue. I have actually done this before on this spreadsheet. So what we get when we add a new calculation is we get this new sheet, which it has all these notes on it. So it tells you what you need to do and what sequence you need to do it in. There's a bit of flexibility in the sequence, but it's just to remind you not to forget anything. And when you've done all that, you can press on the button there again and press continue, and it will go through the information, the extra information it needs. It will just take you through all the information and then finish off the calculation for you and do all that process, which would have taken a long time. They'll do it quite quickly. If we picked it, I'm not thinking too much about what I'm picking, so I know it's not realistic, but let's pick something there. When it changes PHPP, it now doesn't give you the choice. It always shows you what it's doing. So here it's added external wall installation, and it's got a note there saying IOE. That means improvement option evaluation, just so you know, if you ever saw that later, then it would be the PHribbon that's doing it, and it's colored it in red. So it'll either work to a U value or it will just add a specific thickness. So it's showing you it's done that. You can press OK to allow it to continue. It's now showing you that it has removed it before going on to the next one. And the process of getting the PAS 2035 is a lot of the same of that, really. So you would, let's say we add something there. It'll ask you to confirm which cell, and then it'll change something, and then it will change it back again to show you can see that just change back to the unfilled cavity. And then same with all the others. I'm going to cancel that because I think we want to leave some time for questions. But the improvement option evaluation will eventually finish and give you, it will show you a table of the results in the PAS 2035 format. So that's been a brief overview of what's going on with PHribbon updated for version 10. Be very happy to answer any questions.
Great, thanks, Tim. The question and answer session is at 11:30 after this presentation.
Oh, right, yeah, I might have overrun a little bit there. So,
I was being polite.
Okay.
Yes, you have a little bit.
Right.
Yeah.
Sorry.
But that's the challenge, isn't it, of showing something this complex in a very short period of time. So well done.
Do you want me to, will we move to Jurgen's video?
Yes.
Great.
Tim, quick question while we're just doing that. Training for PHribbon. Can that be arranged?
Oh, what you mean one-to-one training, or we already have the videos. Yes, it can be arranged. We'll have to work on that. If anyone wants training, then we can arrange sessions. We always have had sessions. In fact, it's on the website. You can still book training sessions. So
at the moment, it's demand-led, isn't it? You know, there's enough people who want training that we can do it. But we certainly have plans to do this, you know, more seriously, more comprehensively, as soon as we can. Duncan.
Hello, and welcome to this presentation about the Passive House planning package in version 10 and about the new features and properties that we are offering here. This presentation is intended for people who already have some experience with the last versions of the PHPP. So except for the next slide, I will not cover what I'm doing in the PHPP, what happens there, what it can do. But I will explicitly focus on what has changed as compared to the last version. Nevertheless, let me have a very brief look at what it does. So the PHPP basically allows a reliable prediction of energy consumption and at the same time does that relatively quickly, so that you can use it as a design tool to find the best possible solution for your specific project. The results from monitoring show that we have very good agreement on average between what is measured in the project and what we predicted with the PHPP. So here on the left-hand side, for example, we have a group of terraced houses, 32 altogether, and the prediction by PHPP was 13.5 kilowatt hours per square meter in year. Sorry for the German slides here. And the average of the monitoring was 12.8, so as close as you could possibly get. Although there are, of course, individual buildings that consume more or that consume less, but the average can be predicted very well. And the same is also true for refurbishments. Down here, 4 multifamily buildings in Nuremberg in Germany, which have a predicted and a measured heating demand that are very close together. So the PHPP has also been compared to ASHRAE 140, which is an international standard used for the assessment of dynamic simulation programs, or in general energy calculation programs. And it is well within the range that is accepted by that ASHRAE test. The diagram you see here is a third-party test for PHPP10, but we repeated that for the new version, and we got very similar results, which is not specific because we didn't change anything to these central algorithms that calculate heating and cooling demand. These have well been proven for decades. But we changed a lot of other things, and that took some time, much more than we wanted to, much more than our partners and the users of the PHPP wanted to. But the good news is that the PHPP is not only available in German now, but we also have the English version out. And I would like to present to you what we have changed in the PHPP as compared to version 9. Together with the new PHPP10, there's also a new set of building criteria where we tried to make the criteria more precise and to more clearly state what is a requirement, what is a recommendation, what do you need to do to have a passive house that can be certified as such. So this is also available now in English, although the slide is still showing the German version. Right, what did change? First of all, if you're familiar with the PHPP9, you will recognize that the look is slightly different. And starting in the verification worksheet, we put all the project settings together in one corner. There's one small but interesting item hidden pretty much in the lower part of the worksheet that calculates typical interior temperatures. So we know from experience, from large amounts of measurements, that heating demand of old buildings with poor insulation level is typically much lower than what you would calculate if you just assume 20 degrees centigrade room temperature. And the reason is that people are heating part-time and are not heating the whole building all the time because it's just too expensive. So there's a correlation which could be derived between the building standard and the typical interior temperature, so that particularly for old buildings, we can make better predictions of the actual energy consumption. Those of you who are familiar with the PHPP may notice that something's missing here. The criteria for cooling in hot climates have been composed of two different dimensions. One is the annual cooling and dehumidification demand. The other one is the peak cooling load, and this peak load has been removed from the criteria. The reason is that we found that for all projects that have actually been built that did fulfill the cooling demand criterion, they also had a very low cooling load. But there were several cases where quite some effort was required to get the cooling load below 10 watts per square meter, which would not reflect in any savings in running cost, and might even result in increasing cooling demand. So it turned out, after investigation of about 20 different projects in detail, that it might be best to remove that cooling load criterion. So everything has become a bit simpler here. We have a worksheet that is called Overview, that has been here also in the last version, which was structured newly, which got a few new diagrams to better understand how the building works. And in the long run, we intend that to work also as an export area for the Passive House project database, so that all the data that are needed from the PHPP to be entered into the project database can more easily be transferred. There's a new worksheet which is called MONI for monitoring, and this is intended for the comparison of the actual performance of your building and of what PHPP has calculated before. Now, the energy consumption of a building depends a lot, not only on the building itself, but also on how it is run. What are the indoor temperatures? What have been the ambient temperatures, the climate in general during the measurement period? And this needs to be taken into account if we want to be able to make a statement the building is performing as expected or it is not. And that's what this worksheet is providing. So just an example here for the heating demand. The red crosses would be the measured values for heating month by month. The gray crosses are the predictions of the PHPP. And then inevitably, there is a certain range of uncertainty. There's an uncertainty in the measurements, for example, in temperature and heating energy measurement. And also there's an uncertainty in the calculation. And this is also shown here in the diagram, so that if that red cross is between this upper and lower grade line, we would say that's within the expected range. And in this particular example, this is the case in all months. So this might be helpful to understand if the performance of your building is as it should be, as it has been designed. The U-values worksheet has slightly been changed, extended. We added a new data entry for more complex building assemblies. So we can now have up to 5 different sections and a whole lot of layers without needing to extend the worksheet yourself. And in addition, there's a procedure for estimating the U-value of, for example, mechanical fasteners, nails for attic systems or something like that. There's a correlation within the standard ISO 6946, and that has been made available here. The climate worksheet as well has had a few amendments. One is that we can enter a temperature increase in summer here, so that we can model, for example, the effects of urban heat island effects or of a future climate change during the summer month, and we can see if the building is still working according to expectations and is still providing thermal comfort. That's more important for passively cooled buildings than for those that do have an air conditioning. But in both cases, it might be interesting to know. And this has been provided here. Secondly, for buildings in the southern hemisphere, we always needed to use workarounds to like rotate the building and enter the north side as the south side and the other way around. This has also been cleaned up so that buildings in the southern hemisphere can now be entered just as they are, and the PHPP is calculating correctly. In the areas worksheet, there's two main changes. One is a tool that has been available as a standalone tool for a longer period that calculates heat losses from interior drain pipes that are vented through the roof. So in this situation, cold air would enter from below, rise through these drain pipes and then leave the building through the roof. And this causes additional heat losses. And the tool we have here is calculating these heat losses and is directly entering them into the overall energy balance. Number two is the temperature zone X, which we also had in PHPP10, which had one reduction factor for heat losses or heat loads whatsoever. And we found that these reduction factors depend on whether you're calculating heating demand or cooling demand. They may change quite a lot. As you can see here, we assume in this example that the temperature of the adjacent zone is 10 degrees. And then for heating demand, we would have 66% reduction factor. And for cooling demand, it would even be greater than 100%. These reduction factors can now be entered separately for cases when there is something like an adjacent building with a different temperature level. In the ground worksheet, we had a few changes. One of the troubles with the ground worksheet was that people were often entering data incorrectly. You would, for example, enter the U value of the floor slab, both in the areas worksheet and in the ground worksheet. That needs to be done twice because there may be different sections of ground which are calculated separately and which may have separate U values. So when this has been entered and then later on you change that U value and there's not a direct connection in Excel, you might get different entries and you would then get wrong results in the energy balance. So this now results in an error that is reported and that would show you where the wrong input is. Second change, there's additional entries, areas of interior walls toward heated areas. So if you have like a heated basement and an unheated basement at the side, and there's a wall in between that could in principle also be modeled as the basement ceiling from the logic and the heat flows, that would give the same result. But by allowing you to enter it separately, we can first have this error check that's working better and more precisely. And secondly, it's easier to understand for somebody else. Also, again, if you are familiar with the ground worksheet, you will find that we now do not have two different temperatures of the ground, one for winter, one for summer, but instead we are reporting just one heat flow going into the ground. And that's important for climates which are very mild, where you would maybe insulate the building envelope, but not the floor slab, something like Mexico or Southern Europe. And in these climates, the old method occasionally would give strange results, so that we are now explicitly combining the heat flows from winter and summer, heat going into the ground, heating up the ground, saving energy there in summer. And then in winter, that heat would be released and going back into the building. This is now all interconnected and solved iteratively, which gives a more reliable result for any type of climate whatsoever. The changes in cold climates, for example, in Germany, are on the order of 0.1, 0.2 kilowatt hours per square meter in year, so near zero. But in Southern Australia, it may make a difference. Also note that as a physical fact, higher summer temperatures would store more energy in the ground, so that the heating demand will then be reduced, not to a large extent, but there's some interaction that is now reflected also in the calculations. The components worksheet has been extended. So we now have a table of contents here, which can be reached by hyperlinks. And from there, you can go back to the different types of components. So for example, to the glazing types, going from here to the Windows worksheet also via a link, or for the building assemblies, go to the details of that specific building assembly in the U-values worksheet. Also in the components worksheet, we added a filter that would either show all components in the areas and Windows worksheets in the respective drop-down menus, or it would only show the components that are recommended for this specific climate zone. Next one, windows. If you have large complex windows, like the one shown here, this would originally have to be entered as 5 different windows with 5 different sizes, different types of window frames at different sides, each one getting its own shading data. And now we added a methodology where you can just add the window opening and then say, okay, I have a mullion in here and I have a transom, and then these have certain length. So I can calculate this whole thing as just one window, which makes the whole table a lot more easy to understand. And also facilitates the input in general. The ventilation worksheet has slightly been extended. We added 2 features. One is an explicit value for cooling, for heat recovery and humidity recovery in the case of cooling, which may be different from what we have in winter in the case of heating. And if there are data available for a certain component, these data will now be used instead of just subtracting a standard fixed value. Number 2, for larger non-residential buildings, the additional ventilation worksheet has not always been sufficient with the 10 ventilation units that you can enter there. So there's a second additional ventilation worksheet now available. And if that's still not sufficient, you can add others so that you can model very complicated ventilation systems in large buildings. The heating worksheet, as I said, is virtually unchanged. What changed is just the representation here on the left-hand side, which shows an energy balance for the heating month, and it is not always easy to determine which is a heating month. But in PHPP10, it's those months that have more than 1% of the total heating demand calculated, and that gives a much better energy balance, which is much more easy to interpret than it was in the old version. The same is true, by the way, for the cooling worksheet. Summer comfort becomes more and more important, so we added a stress test for summer comfort directly in the summer worksheet without you to having the need to enter variants to add to make complicated investigations yourself. So we are calculating the building as designed. Sorry, here we are, giving us a certain frequency of overheating. And then we have different changes to that design. So for example, reduce the summer ventilation rate, reduce the night ventilation rate, reduce the way temporary shading is being used, increase the internal heat gains, increase the ambient temperature because it's a warm summer or climate is just changing. And we see what the frequency of overheating would be in that case. That will allow you to better assess if the building will work under more difficult circumstances or if it will then become uncomfortable in summer. This is the new cooling units worksheet. Two weaknesses of the old cooling units worksheet were that you could only enter a standard, a fixed value for the seasonal energy efficiency ratio, which you did not know how to determine. So that was always a bit of guesswork and estimate. We are now able to enter in the components worksheet the actual properties, the performance under different boundary conditions of the cooling systems involved. And from that, calculate the seasonal energy efficiency ratio. And number two is that there have often been cases when the cooling system was not sufficient to provide both cooling and dehumidification appropriately, which can be the case in reality. So if we have a split system that is just moving a lot of air and is providing very little dehumidification, but we mainly have a dehumidification load and not so much a sensible load, then there is a problem and that needs to be shown. However, we are now able to model two different modes of operation, a standard mode and a dehumidification mode. And the worksheet will automatically mix these two modes in order to try and see if the cooling system can cover the demand or not, which hopefully will simplify the verification of cooling systems in humid climates. Now, domestic hot water distribution systems. Domestic hot water is the major energy consumption together with household electricity in a passive house. So we are very good at heating, but the useful energy demand for domestic hot water is on the order of magnitude of heating in a passive house plus distribution losses. And so we improved the way or added additional options how hot water distribution systems can be modeled. Without going into too many details here for time constraints, this is the standard system, one circulation line for heating, another one for domestic hot water. And if we use heat interface units with 4 or 3 or 2 types, pipes, we have the chance to reduce the return temperature and thus reduce the circulation losses, apart from the fact that 2 pipes obviously have lower losses than 4 pipes. So this can now be modeled without using any workarounds directly in the PHPP. Also, the internal heat gains from the domestic hot water system are accounted for separately for winter and summer. They would be a bit lower in summer because we have higher room temperatures and thus a smaller temperature difference. giving us less heat transferred from the domestic hot water system to the room. Next one would be the PV worksheet, where not a lot has been changed, just the standard systems, because PV modules have improved during the last years. So there's a more realistic or more current standard PV data set integrated here. The electricity worksheet has a few amendments, so we changed the structure. We added data for energy in operation and energy outside operation, so in standby, for example, to be able to model that more precisely. And the standard values have been revisited, including the data for small devices like telephones, TVs, microwaves, and so on. For electricity in the non-residential sector, also a few simplifications have been made. So there's now standard values for electrical devices, so that I can choose a standard laptop computer, a standard display and the data are already proposed here. But still, you are able to use user-defined data, enter them down here in the second section. Auxiliary electricity had a few changes. One is that there's a methodology for fan coils already integrated. So by just entering the electric power of the fan coil, we can estimate the amount of electricity that is used over the year, depending on the heating and cooling demand. And also we found it useful to have the inverter of the PV system. More and more buildings have photovoltaics, and the PV inverter has a certain amount of losses that may become released in the thermal envelope and would particularly heat up the building during summer. So that should be reflected in the balance, and this is now automatically calculated from the data of the PV system, and in particular the losses for the inverter that are entered there in the PV worksheet. PER calculation, primary energy renewable, has proven to be a good metric for the sustainability of a building. So the tendency that primary energy factors, carbon emission factors, particularly for electricity, are changing constantly, are being reduced year by year, luckily, makes it very difficult to use them as a metric for whether a building fits well into our future. And looking instead at when the transformation of the energy system has been finished, when we have only renewable energy, how much of that primary renewable energy that needs to be produced is actually needed by the building, tells us if the building is one of those that we should have in the future. So the calculation methodology that we already had in PHPP10 has in principle been kept. What we changed was that we can now enter not only 2 but 4 different heat generation systems in the PER worksheet. And there have been some changes to the way bioenergy is assessed. and also to the way district heating is assessed. Calculating district heating is difficult in the PER system because if we enter the data of a current district heating system that is running, for example, on coal, that would definitely not be, we would not be able to fulfill the requirements. But the district heating systems also need to be changed in the near future, so that we decided to allow for a standard district heating system. And you could just go into the PHPP, go to the district heating worksheet, and then check I'm using reference district heating, and you don't need to enter anything else. Or if you are interested in a detailed calculation, this detailed calculation is available, so we can have different heat generators with different energy carriers, with or without CHP, that will then be assessed with regard to PER as well as to primary energy and CO2 emissions. And also a calculation of the heat losses of the network is provided up here. That would show you how much energy is lost in the distribution network. But as I said, in most cases, it's not necessary to calculate that in detail, particularly because it is also a moving target and changing over the years. Instead, if you check reference district heating, you can use that for assessment and certification. One more, heat pumps. Heat pumps are becoming increasingly important, and we used to have a heat pump calculation already in the PHPP, or to be more precise, two of them. One for compact heat pump units, those systems that have heat recovery plus heat recovery ventilation, plus a heat pump, plus a domestic hot water storage, plus the heating of the supply air. But there's lots of other combinations and systems already on the market or emerging. So there's also the heat pump worksheet, which is just calculating heat pumps without any additional surroundings. Or what's becoming more and more popular are these combined ventilation and heat pump systems, which provide ventilation, which are coupled to something like a mini split, and can thus provide heating and cooling and ventilation and dehumidification all in one system, including the distribution in the dwelling unit. So there's a number of manufacturers in China, and these systems have already been certified and are available to be chosen in the PHPP. And of course, there's the split systems, so mini splits, multi splits, VRVs, that can also be modeled here, and we can now enter more detailed data together with the other components in the components worksheets. Right. Apart from the changes that I mentioned, there's a lot of other small improvements in the PHPP, which I would not all mention in detail here. I would just like to say that there's also some tools around the PHPP, which are not part of the actual Excel worksheet. And one is this room schedule, this room data book, which contains the data for every room in the building. So one row would be one room. And from that, it automatically calculates sums, averages, and whatever you need to enter it into the PHPP. So for large buildings with different utilization patterns, it may be very helpful to have such a clear list of rooms and having all the information that relates to one room collected together in one row here, such as treated floor area, the indoor volume, the utilization type, the lighting requirements, ventilation, apartment size, building sections if there's different temperatures, or some other entries. So that's about it. Thank you very much for your attention, and I'll be happy to answer any questions afterwards.
Thanks, Jurgen, or thanks Jurgen's recording. As we know, Jurgen's with us live to answer some of these questions, which have started to come in now. So what I'll do, there's a couple of questions that sort of cross between Tim and Jurgen, but Jurgen, how many users of PHPP do you think we have at the moment? Do we know around the world?
We know, but I don't know about now. So.
Is it? I've heard a figure of 10,000. Does that sound about right?
Sounds reasonable. Yes.
Yeah. Okay. We'll stick with 10,000 then. Okay. So we've had a couple of questions for you. One from James. He's asking whether you have any plans for a light version of PHPP, which suggested. I seem to remember many years ago, was there not a planning version of PHPP, which was just that, to do sort of quicker feasibility study calculations, or have you kind of used Design PH to do that function?
Yes, well, we had that what we called like a pre-planning package, and actually that's still available, but I'm not sure if we ever translated it into English. So that was just providing a very much simplified energy balance, and we do intend to provide something that is a simplified single-family home calculation method, so that you're not confused with all the things that are just for non-residential buildings, just for buildings with active cooling and so on. But unfortunately, I can't give you any time frame when that is supposed to be available. But
you've identified it would be a useful thing to do.
Definitely, yes.
Right. Oh, that is an interesting answer.
I mean, all the time we find that it would be helpful to have some additional feature here or some additional precision there. But of course, it always adds to complexity, and so we are trying to balance that all the time. But in the end of the day, the PHPP is just growing in complexity.
When will it attain self-awareness? Soon. Okay. I think this is a question possibly more for Tim, but it's Keith has asked. I think he's noticed possibly a supplier of Windows, certified Windows, that you've got certified. How do those products find their way across to PHribbon? Is it done in batches? Because I think Keith noticed that his product wasn't listed. It was
the Hewick Aluminium Systems window that he was talking about is actually part of PHPP version 10. It's actually listed in PHPP itself. But the list that's in PHribbon is really for a customizable list of your own windows that you commonly use. And I just built that list up myself over time of windows I was asked to use. So it's a very simple thing, probably customizable, really. Most relevant really to your own choice of what windows you use, but I'd be happy to add them if they weren't already in there.
Thanks Tim. I've just noticed a little flurry of questions. That's good. Quick one here. When will PHPP10 be available to buy in the UK? Jurgen, put you on the spot again.
Yes, very soon. We have some administrative issues to solve, which is really quite a nuisance, but with just details of contracts that need to be fixed or need to be sorted out.
Could we say a week? Do you think? I mean, is it of that order, or is it?
I hope we get that finished within a few days, so that
Okay.
well, say by the end of the month, that should be available.
It's sitting in customs. It's Brexit. You know, you've got the documentation to fill out before before you're allowed to send it through the ether. Yeah.
Bound to be Brexit. Okay, so there's a more technical question here. Colin has asked, you showed a slide that showed zones. Is this derived from the detailed room data sheet? And can this predict overheating within specific parts of the building?
Well, we can't predict overheating in specific parts of the building, because if you want to do that with some appropriate accuracy, you would need to consider like all the interactions between the different zones. So it's not only what is the window size, what are the solar loads and the internal loads in my specific room, but it's also how is this room losing heat to the other rooms in the building. And that interaction is not negligible, and it would require a full-size multi-zone simulation, which the PHPP is not providing. We always thought about offering something like an individual critical room that is in contact with all the rest of the building. And in principle, this seems to work in the sense that the results agree sufficiently well with a detailed dynamic simulation. But well, so far we didn't manage to make that available. The zones are still referring to that room data sheet where it makes sense to order the information differently. So room by room or zone by zone, and to put all the information about that one room like into one row.
Thank you. Okay. Jeff, did you want to come in at this point?
Well, yeah, I mean, look, thanks, Jurgen, for a very important presentation. I should say that the thing that that jumped out at me most with PHPP10 that I suppose just because it's a pet subject of mine, was this ability to change the temperature in retrofit in pre-retrofit buildings, because we know that you know, comfort taking is something that occurs in retrofit, but it's, you know, pre-retrofit you have this what they call the pre-bound effect, isn't it? This thing of people suffering, especially with energy and energy crisis and the cost of living crisis that we have now. So being able to adjust the source temperature pre-retrofit to the kind of Dickensian misery that a lot of people will be kind of living through now is important, frankly. You know, it has to come into it. And I think it's important as well because, you know, it enables us to, and I think it's important that users of PHPP do this and utilize this when, I'm sure they already are when they're discussing this with clients, the non-energy benefits of retrofit, you know, getting people to consider how different the building will feel post retrofit. You know, I think that's an important point. What I wanted to do, if it was okay to not hijack this,
we've finished the question, so you know, yes,
okay,
I think it's fine to carry on.
Great. So look, I mean, as some of the delegates here may know, we have been working with the AECB at the magazine to use PHribbon to start to really kind of try and number crunch embodied carbon. And the great thing, the thing I love about it as a tool, just like PHPP, is the transparency of it. Life cycle assessment tools a lot of the time can tend to be sort of informational black holes. You know, they suck light in and let nothing out. And Ribbon, in that regard, is certainly something of an exception. It's been fascinating from my perspective because when I get the calculations back, and this has been different to my experience with some other calculation tools, I can actually interrogate them. I can dig into them and look into the formulae underpinning a given result and understand what's going on. And, you know, that's so important. If we're to move away from a situation like we've had in the past, where LCA, where it has been done, it's been part of, you know, standards like BREEAM, LEED, and so on, and it's just been a kind of an afterthought. You get points for it, so you do it after the building's finished, and you find out what the overall score is. You get a consultant to do it, you get the result, you don't question it, and that's that. But really, what we need to do, we need nimble tools that are quick and easy to use, and that enable us at early design stage to work out the impacts of decisions that we might choose to take. So we undertook a project between the Passive House Association of Ireland, which I'm a board member of, and the AECB a few issues back at the magazine, where we got an end of terrace house type provided by Cork City Council. John Moorhead, the Irish architect, arranged that. And we took, initially it was 5 or 6 different wall types, and we assumed minimum compliance with building regulations. You'll notice not particularly generous thicknesses of insulation, these SketchUp drawings that Andy drew for us. 0.18 U value, I think we assumed in each case, essentially. And the variables you can see here, let's see if I can look at it right, there's cavity wall with brick, with like a PIR insulation and brick clad sitting on a conventional foundation. There's cavity wall, the second option, there's cavity wall with rendered blockwork. The third one is, what is that? External single leaf blockwork with external insulation on strip foundation. Then the fourth one is, again, that wall type that's sitting on an insulated raft foundation system. And then the fifth one is an I-beam timber frame with cellulose, again, on the insulated raft foundation. So that was a really interesting experience, because, you know, it was an opportunity, I felt, that for us to kind of actually try and know, you know, work out in embodied carbon terms what the scores were for each system, rather cut through the kind of marketing spiel and actually try and learn something. And the next slide Andy has here was we expanded upon that. And sorry for bamboozling you with an impenetrable table, but we added another 6 wall types, including 2 insulating concrete formwork walls and 4 more timber frame variants. This is in conjunction with the Irish Timber Frame Manufacturers Association. This is just described in detail in issue 41 of Passive House Plus, which many of you, I guess, will have received in print, and it's also it's available for free online. But on our website. But what we have in this table, we've ranked the 11 different wall types, and they're ordered here by their overall embodied carbon scores. The different cells, the different columns here, A1 to A3 is the emissions released into the atmosphere by the construction products used to build the building, to build the walls. In each case, I should say, for these 11 wall types in this case, we to simplify matters for this analysis, we sat them all on insulated raft foundations, because it just meant that the area of the walls was exactly the same in each case. Whereas if we'd gone with strip foundations, it would have differed depending on whether it was external insulation and you had to bring the insulation down below the floor or not, you know. So there was a consistency in that. We're trying to compare like with like. So we went from the I-beam timber frame through to ICF, insulating concrete formwork. And with the ICF, we had 2 variables. We had a bog standard ICF with an awful lot of high cementitious content in the concrete, a high amount of rebar, and no cement alternatives. We looked at an improved ICF variable as well, which had again, still within the normal bands of what you'd see from ICF suppliers, lower cementitious content overall, because they really tend to chuck cement at concrete and ICF walls, and lower rebar, and then high cement substitution with GGBS granulated blast furnace slag, which is a low embodied carbon alternative to Portland cement, which seems to have had surprisingly little traction in the UK, actually. So an aside. But you'll see here, we've ranked them all. A1 to A3, that first cell is emissions released into the atmosphere by the products, by the point of manufacture. The next one along, A1 to A3 sequestered, is the emissions sequestered by biogenic materials, so timber based materials, for instance. So that's the amount that's been sucked out of the atmosphere by that stage. A4 is transport to site, and A5, we omitted A5 because the calculation recommended in the UK methodology RICS is based on the value of the project, and that we didn't have those figures, so it wasn't really relevant. B1, B2, and B3 is essentially and B4 and B5. They're various stages of the use phase of the emissions related to repair and replacement and maintenance. And then C1 demolition we omitted because again it's based on the value of the project. So and the other stuff within module C is related to the end of life. So the total on the right hand side probably is the thing that's most worth looking at, I suppose. And what you see here is that the I-beam timber frame is 4.1 tons of embodied CO2 equivalent, whereas the bottom option, you can just about see on my screen, is an ICF wall, the standard ICF wall, which is 15 tons. That was a kind of a jaw-dropping moment for me to see quite how stark the contrast was. And ICF, we did manage to improve it, but with all of the efforts that we made, we only brought the improved version up to 9th out of 11 on the list. The other kind of big conclusion, I suppose, from this, you'll see that the brick-clad variant and the brick slip-clad variant, we had a brick slip-clad external insulation system. It's really hard to justify brick in embodied carbon terms. Yes, there's arguments around the longevity of the product and so on. And architects love bricks, and that's an important part of your heritage in the UK. I understand that. But brick manufacturers need to find ways, I don't know how you do it, but to massively reduce the carbon of that process. You could say as well, the methodology that's used for calculating the overall cradle to grave figures is harsh in some people's eyes, at least, on timber. It regards at the end of life any stored CO2 in the timber as being released into the atmosphere at that stage, or at the very least going beyond the boundary conditions of the life cycle assessment. So basically it means that if there is a benefit if that timber is salvaged from the building and used somewhere else, the benefit of that sequestered CO2 passes on to the next use. So some people, and you might say this is a bit disingenuous, would look at that result on the top there, the timber frame I-beam one, and see 3.5 tons up front and minus 5.4 sequestered. And you could argue, the LCA people frown upon it, and I think probably correctly so, that there's more CO2 being stored in those products than was released in their manufacturer. And that, of course, that kind of magical thinking tends to lead to people saying, well, the way we solve our environmental problems is by deforesting, basically. But anyway, I just wanted to say in the round, I'll stop myself there. It's been a fascinating experience. We're learning all the time through using these tools. The great thing about Ribbon in this regard too, if you're a PHPP user, is that it's done a lot of the heavy lifting. If you've put the building into PHPP already, you've got the dimensions. You've got the quantities of the materials you can work out, and because of course with Passive House, this kind of substitution of equal or approved and value engineering, where you cut all the joy out of everything, can't really happen. You've got to you've got to keep really good, tight control over the spec. And that makes life much simpler when it comes to LCA. I've seen some other projects where we've been attempting to get the data for an LCA calculation, and the architect may not know what the actual material specification was. That doesn't tend to happen so much with passive house projects, especially if it's going for certification. So you end up in this situation where a process that in the past may have taken weeks and huge expense to complete, it's possible quickly and inexpensively to get the calcs done and to actually understand these things. So it's been a fascinating experience, and I'd encourage everyone to use it.
Thank you, Jeff. So we're aware that Jurgen very kindly is sort of here to pick up any questions. One more has come in, and I know, Jurgen, you need to leave sharpish at 12, don't you? So I think we can just sneak that one in if that's okay.
Yes. Yeah.
Did you? I've just texted it through on the chat box, but basically, you're being asked: is the temperature entry on the verification sheet for existing buildings doing something similar to the Passive House Trust add-in sheet? I don't know if you're familiar with that, the intermittent heating sheet that Passive House Trust have published.
I think I've seen that, and it does in a way something similar. So what I can say is what we do, we looked into a large number of literature results of what existing buildings are consuming as compared to what you would calculate, assuming like 20 degrees indoor temperature. And we found a correlation that we could relate to the heat losses, the specific heat losses of the buildings mainly, and also to the size of the dwelling unit. So if you have just one large building, the chance that certain rooms are not being heated is bigger than if you have a small apartment. And also within an apartment block with small residences, you have larger thermal contact between the different apartments. So it's not so easy to bring the temperature down of one single room. So that's also entering that calculation. And that way we were able to do that climate independent. So it should work in different heating and also cooling climates, although we have no real verification for the cooling case. That's what I have to admit. It's just the best estimate we can currently make. Yeah, so that's what the PHPP does. And I think what the Passive House Trust sheet does is, as for the results, it's something pretty similar.
Yes, we'll have to, Tim, we'll have to sort of try and make sense of those two different options then for this. That's not a curveball, but we need to think about the relevance of that intermittent heating sheet with the new feature of PHPP10.
Yeah, so thanks everybody, and I will have to move on.
Yes, thanks
to
again.
The next meeting. So and have a good conference for the rest of the day.
Thank
Bye.
you. Thanks very much. So I think, Duncan, have we reached our allotted end for this session?
I think we have, Andy. I think that was really valuable. So yes, our next session is at 12:30 with Sarah and Tim from Sarah from CODA on Part L of the building regs. So yeah, we'll see everyone back at 12:30.
Okay, thank you, everybody.
Thanks, guys. Bye.
Bye for now.